Hello everyone. Today we are going to start the very important part of GIS, that is analysis. As you know that we started with the first what is GIS, definition of GIS, and then different components of GIS, different types of data which GIS can handle, how we bring data into GIS, then database system which we have also discussed, and finally now we have reached to the real operation of GIS, and this is in three parts, the GIS analysis. So in first part we will discuss the simple primary operations in GIS in little detail. And as you know that we have discussed about primary operations and secondary operations. So in primary operations or basic functions of GIS, usually we call them as tools, and this we have discussed about area and distance measurements, buffer generation which we will discuss in later lectures, and reclassification which we will discuss here now. So in data analysis operations, the first thing starts with the data selection and query or data retrieval, because if you recall the definition of GIS, say efficient retrieval of the data. That is one of the purposes of GIS. So this retrieval has to be very efficient, and there are different tools and techniques are available, so which we will see, and we will also discuss reclassification in this particular lecture, overlaying operations and other neighborhood operations, connectivity operations, all these we will discuss in later analysis, analysis 2 and 3 lectures. So first is about attribute and spatial query retrieval. As you know that there are two sets of data in GIS we put, one is spatial data, another one is attribute data, or we also called as non-spatial data. So if we take the example of say point data is a spatial data which is having just x, y coordinates, no dimensions, but it can have n number of attributes, and this there is a dynamic linkage between attribute data and spatial data. So whenever we query spatial data, be the same time the objects which are satisfying this query on attributes, then they are also selected, and in reverse way if we do certain selections or query over spatial data, at the same time our attribute data are selected, and then we can retrieval, that means we can save them as a separate file. So a subset of the data after the selection can also be created very easily in almost all standard GIS software. So this attribute query, you can perform query either on spatial data or on non-spatial or attribute data. And so this query involves the processing of attribute data independent of spatial information. And in the reverse way, in the spatial query, it involves the selecting of features based on their location or spatial relationship. As I have mentioned, there is a dynamic linkage or hot linkage between spatial and non-spatial data. So any operation you perform on one set of data, automatically the similar operations are also performed on the another set of data. And this the spatial analysis functions which are in GIS, these tools are available which involves both attribute and spatial data queries. Now spatial querying is basically the process of selecting features based on certain conditions, and these conditions the GIS user will put based on maybe on locations, based on maybe the spatial relationships. For example, selecting all features within 300 meter of a road. So you are putting these 2-3 conditions, that there is a feature which is a road feature or a road network, and then you are saying that whatever the features which are falling within 300 meter on both sides of road should be selected. Once they are selected, you can save as a subset of the data. And function that allows a user to find, display or isolate attribute records linked to map features. That means there is a dynamic link between both the things, and this can be on a spatial data. You can make selections based on windows, and these windows can be of any shape and sizes. You can have circles, polygons, trace, whatever the graphics which you can draw on spatial data, on that basis the selection can be made. If you are already having certain boundary, for example, if you are having a blazes of India plotted in a GIS and which are being displayed. Now you want to only select the blazes of say Uttarakhand. So you need to have the boundary, polygon boundary of Uttarakhand, and once you instruct or make a special query that whatever the blazes which are falling within the boundary of Uttarakhand, these should be selected. Once they are selected, you can save as a separate file. So a subset of blazes of India will go as a subset of Uttarakhand blazes. So this way, that is why it is called also retrieval, selection and retrieval. And data retrieval, as you know, involves the first you have to search, manipulation, that means only selected features you are doing, and then output of data without requirement to modify geographic locations of the features. When you make the subset of the data, you are not modifying the data, neither you are changing their spatial location. What you are doing, you are just extracting the data, making a subset and saving as a separate file in your system. And as has been mentioned already, that spatial and non-spatial or attribute data are having linked, and no changes are made to the location of spatial elements. This is important. Whenever you perform a query, original data will remain always intact unless you go for editing and change the data. Otherwise, query will never modify a data, and neither your retrieval. And no new spatial elements are created. Once, since you are not modifying, you are not editing, and therefore new addition will not be made. Only the subset of the data will be made unless you instruct the system. And to find out what exists as a particular location, so you start getting answer even during selection and querying processes, that what is at that location. Retrieval of data, you can have a point data, line, polygon, or mapping units of a raster. So on any type of data, any type of vector, any type of raster, you can perform spatial queries. But remember one thing, vector data can have n number of attributes, whereas you know that raster data will have only one attribute. So based on that particular attribute, you can make the selection and can retrieve the data, which we will see little later. And retrieval of information using conditional, logical or arithmetic operations. These tools are also available under a category which is called a spatial analysis. Sometimes depending on the software, if you are using say ArcGIS software in which there is a spatial analysis module or extension is there, when you switch on for this extension, all these tools are available. And also these tools like conditional, that if a map is having say elevation more than 1000 meter, then all those cells which are having satisfying this condition should be selected. So you can make these conditional queries, you can have logical queries greater than, smaller than, and so on so forth. You can have arithmetic operations, plus, minus, multiplication and subtraction, all kinds, and in combination also you can have logical operations based on Boolean logics can also be performed, like A union B, A intersection B, all those things, but we keep them as a separate category which we call as overlay operations, which we will discuss later in other lectures of GIS analysis. So let us look first the data retrieval using a raster model. Raster model will only have one attribute. As you can see here, there are three raster layers are there. One is soil, another one is rock, third one is slope, and it depends on if you just select a cell over raster, all corresponding cells in all remaining layers will also be selected, and you get information that here the thickness of the sand in case of soil is this much, and all those details can be retrieved. So map 1 is having soil say 2, thickness that soil type is silt, thickness is 5. In map 2, which is the rock map, is having rock granite, and is strength is high if that attribute information you have kept there, or map 3 here you can have a slope map. So, it is telling there is a gentle slope. So, all this information can be retrieved, and there is no limit basically. Theoretically there is no limit. You can have retrieval of data in case of raster or vector of tens of layers together. So, that is very good advantage working in GIS. Now, search functions can also be used, which constitute one of the most commonly used neighborhood functions. So, search functions will do the searching as per your given conditions in the surroundings, in the neighborhood, and they will determine the value of each target feature according to some characteristics of its neighborhood, and these characteristics, if they are stored in the system, then you can definitely retrieve. Region of interest or search area usually can be square, rectangular, circular, or it can be of any arbitrary size, but these have to be polygon in shape, and then you can retrieve. Also using polyline data can also be used, and all these will be determined by the analyst. The size and shape and other things can only be fed by the analyst himself, the GIS expert. Now, the second one after the data selection, query, retrieval, and now we come to the reclassification. Let us look by reclassification, because sometimes you are having a map, say a polygon map, which is having a geological information. So, I take that as an example here, that here basically we want to classify that map. Instead of simple as a geological map, we want to classify the rocks which are present based on their ages. So, that is what the reclassification is. Now, same thing, same map, if we are having information about strength of different rocks, we can also classify the same map based on the strength, and these type of operations we call them as reclassification. So, reclassification involves the selection and presentation of a selected layer of data based on classes or values of a specific attribute. That attribute has to be there, and based on that attribute you can reclassify the data, so that the presentation style becomes different and that map becomes more appropriate than a very general map. And it involves looking at an attribute. That attribute, if it is already having the age of the rocks, for example, then you can use that age attribute and reclassify, or a series of attributes you can also have of a single data layer. And generally the reclassification is done on a single layer, say polygon layer, and reclassifying the data layer based on the range of values of the attribute. You can also, if you are having a continuous map like a digital elevation model in which elevation are changing in continuous fashion. So, suppose you are having a range of elevation, the minimum elevation is 0, maximum elevation is 1000. Now, you can reclassify this map. Instead of a continuous, you can segment it, and you say that I want to have 10 classes starting from 0 to 100, 101 to 200, and so on and so forth. So, the range of values can also be used of attributes to reclassify a map. And then reclassification of a soil map, if you are having already a pH value against individual polygons of soil map, you can reclassify. Reclassifying an elevation, as I have already explained about this part, that into different classes, and the range user can define. Or if you do not want to define, you want to use some statistical methods, then those tools are also available, which we will discuss in later classes of GIS analysis. So, the classification basically based on the number of classes before and after classification, and three types of classification can be used in GIS. First one is one-to-one. So, these are looking basically the relationships, and the second one is many-to-one, and third one is one-to-many. So, one-to-one involves the number of classes before is the same as number of classes after the classification, and there are no changes in geometry of spatial objects, they have been reassigned. So, whatever the say a polygon map was there, you have reclassified the number of polygon maps which were earlier being displayed, same numbers will be there, only their attributes will change. And many to one is the number of classes after classification is smaller than number of classes before the process. And this brings the generalization or aggregation or merging also. These generalization and merging and aggregation, these things we have discussed in other lectures. And last one is one to many, that initially you had few polygons, now in a reclassified map you are having many polygons. So the number of classes after the classification is more than the before the classification. In vector format, spatial objects are split in different objects. In raster format, for example, unique IDs are assigned to each pixel in the output map. Let us look the example. Example is a geological map which is being displayed here. Different types of lithologies are presented here. Now we can, if we are having in our attribute table, see this is the classified. So we have now number of classes here where more than 20 say. Now we have reclassified and we have used the age as a one of the criteria and reduced the many to one. So we have reduced from many more than 20 classes to 7 classes. So what happened that many polygons which were there now have reduced, and this whole area if we see there were many types of lithologies were present, but when we brought the ages of these rocks, and these ages are quite broad ages, and therefore lot of polygons have disappeared and only large these classes are coming here. So number of classes have reduced, and therefore the interpretation, if we start interpreting this map, it is rather difficult because classes are many, too many, but here number of classes have reduced, say in this example 7, and therefore interpretation of such maps or presentation of these maps becomes much easier and useful also, because now we can understand different rocks based on their ages. And as say in earth sciences, in stratigraphy, we always try to present rocks in their ages. So that is the advantage of reclassifying. But this information has to be there in your attribute data. If this information is not there, then it cannot be done. However, if we by some source, if you can add that information into attribute, then definitely you can achieve such type of classification. Now the same map which is being displayed here, if in attribute data the different lithologies informations are there, we can we can merge them. Here the lithologies are presented, but we have merged them into 3 main types of rocks: igneous, sedimentary and metamorphic, and therefore number of polygons and number of items in the legend have reduced just to 3. So this is really an example of many to one classification, and map has become further simpler and very easily understandable that where are the rocks, where are the sedimentary rocks, where are the igneous rocks and metamorphic rocks. So this is the advantage of reclassification. Similarly, a reclassification of a map here is given here, that attribute here we are using land use, and there are street maps and there are city blocks or where the houses are built up. So you can use a table from here and then change to say land use. So land use, this map has been changed to land use. Now land use is showing, say red color is showing residential. So all residential plots have been given a color which is red color. All recreational areas, say garden or some playgrounds, have been given green color, and so on and so forth. So this map initially, which had attributes like this, if we use this land use attribute and reclassify this map, then these maps becomes much easier to understand than the map which having the different numbers, and you cannot identify easily that which are the residential areas unless you see their attributes. But here, using that attribute, we can reclassify and map become easier. So that is the main purpose of reclassification, is to either merge it, aggregate it or generalize it. That is the main purpose. So, this is a more or less example of generalization and merging together. Now in case of raster, again reassigned based on the attribute value. So now 1 to 1 means no changes in number of polygons. Initial map has the 3 polygons, and 3 different soils also had an attribute information about the infiltration information. So I can here soil type 1, 2, 3 have been reclassified based on their infiltration value. Now class 1 of soil and 2 are having the same infiltration values. So therefore the boundary has disappeared and they are all getting one color, and then class 3 is having infiltration value 25. So now it has reduced here number of polygons, but as you can see that since both are having same color, therefore they are appearing as one, otherwise there are 3 polygons in this particular example. Similarly, here assigned based on the attribute name, we can also use nominal attribute and reassign this thing. So if they are having certain names which are present, and we say that these are the equal one, so this has been assigned to 0 value, and then next one is assigned the 3. So again you have reduced number of polygons here, because the condition which was put is if the soil equal to red Gina, then the value should become if it is okay, then value should be 3, otherwise it should be 0. And so this kind of syntax you have to put into your special query. Now another example of reclassification is using a table, again here that initially there are 3 units, same example, and then it has gone to this one. Now data classification by slicing, this is a very common technique in digital image processing of remote sensing data as well, where we use the term which we call as density slicing. So on a single layer you can regroup the number of values, pixel values, into say you are having a 8-bit image, and which will have values between 0 to 255. That means initially they will be having values of 256 classes. Now these 256 classes you can reduce to 8 classes by giving a range of values and assigning a color, and once you do it we say is slicing or density slicing. Similarly here, that a digital elevation model is there which is a continuous, in this example it is representing continuous data. Now we can reclassify and give the range of elevations, that the range of elevations are between say 0 to 200, and then 201 to 400, and remaining 900, and when we assign different colors, then here we get this kind of map, which is now classified map, and we also sometimes call this kind of map if a continuous data have, especially elevation data, have been reclassified into certain classes, we call them as relief map, as example is shown. It is a very simplified example here, but just for understanding that instead of having continuous data you can discretize the data by classifying. So legend can also be seen, that here see it is a continuous legend 0 to 900 meter, whereas the legend here you are given 3 distinct colors and their ranges are also here. Now you can also do automatic classifications, because once you start involving your statistics here of the values and their ranges and their variations, then you can bring statistics directly, and for example you can use equal number, equal interval or equal frequency, and then you can classify. So their examples are shown. This topic of classification techniques based on statistical methods, which we will be discussing in much detail in later lectures. So here the examples are given, that this is the original image, it has been classified based on the interval, it is classified based on the frequency, number of occurrence of values. So this brings to the end of this presentation on the first one on GIS analysis 1. And in next lecture, we will be going much deeper into analysis 2 and then next analysis 3. So, for time being, thank you very much.